Hello, hello, happy Sunday, everybody. This is Quad Hawkins back for another RHCSA style exam. Today we're gonna kind of re rehash the old topic on this partitioning, swap, and LVM storage because I feel like this is a very important concept to really get muscle memory down and kind of know the flow of um, managing or resizing LVM storage or partition storage or just storage in general. I mean, this is a storage is a big exam objective from what I've read or from what I've heard in the community and I don't know if you guys can keep me honest or not if it's weighted differently, if anybody's taken the exam, is it weighted differently? Or storage, is it weighted higher or any or all the same? But if so, just please drop a comment in the video. But let's get to it. So our lab scenario, so we're still we're going to be we're just acting as Linux systems administrators here, and we work for a company called Nebula Systems. So we have a new disk. Called NVMe 0N2. And to see that is, let's take a look at what list block devices do we have. So you use the LSBLK. This is what we have, 20 gigs. So our that has been attached. So our job is to prepare a structured storage for different teams. We're going to configure swap for system memory support. We're going to use LVM for flexibility and scalability. And we're going to ensure everything persists at reboot. So now, some of the prerequisites, we just did one. We want to check what available disks we have. So we have this I added before. I added is NVMe2. Probably seen this in many of my other videos. So we're just gonna work off the same disk. So what's happening when I use this command? So this blocks all the lists all block devices. So we've confirmed that we're using the NVMe 0N2, and now this this kind of prevents accidentally modifying the wrong disk. So always want to make sure and always re-verify everything you do, every task you do. So now, now if we now if we want to clean the disk, we're not going to worry too much about that, but let's just pretend it is. But so let's go over and kind of set up the environment, what we want to do here. So now let's go ahead and create our directories that we're going to need. So we're going to need an apps directory, a logs directory, a backup directory, and a temp data directory. So to do that, we're going to do mkdir, all right, dash p option, all right, slash apps, slash, uh, oh, slash apps, slash logs, slash backup, and slash tmp data. All right. All right. So these are our data. All right. So what's happening here is we're creating these mount points, these directories as mount points before we attach the storage. So the dash p option ensures no error is in no ensures no error if the parent directory already exists. So this mimics kind of real production environments. So next, we're going to go ahead and create some groups. We're going to create a group called app team and log team. So let's go ahead and use the group add command to create. This is a command to create groups. Group add app team. All right. And then we use the same thing, and we're going to do the log team. Okay. All right. So let's set ownership of the each of the respective uh I'm sorry, the to the paths here, to the app, to slash apps and slash logs directory. So to change, so if you want to see that right now, so we're gonna do ls dash l, say slash apps, apps, I'm sorry, ld slash apps. All right. So we currently have they're currently are owned under root because we are root and we created these files. So let's go ahead and clear this. Let's go ahead and clear this. All right. So let's go ahead and assign group ownership to let's go ahead and share group ownership to the app slash apps logs is going to be owned by the app team. Logs is going to be owned by the log team. So users in these groups will share the access. So to change ownership of a group, you've seen this before. So ch own, all right. And here you can do it many different ways, but let's say we're just going to put app team and slash apps. All right, there we go. Let's do the same thing. Let's change this to logs. All right, let's change, just dock this up a little bit. Log team, log team. All right, all right, all right. So we changed ownership to those. So let's go ahead and do another ls on. Let's check that again. All right, and let's check logs. All right, there we go. So root owns the file, owns the files here and directory here, and app teams, the root app team and log team own their respective mount points file systems here. So that's clear. All right. So next, we're gonna set SGID bit on the apps and slash logs directories. All right. So now, as an SGID, as you guys will know, so pretty much any new files that are created in here inherit the group. So the group, so and anything that's created here, whether I create a file or someone else creates a file, the app team owns that file. So let's go ahead and create it. So to do this, we're going to do chmod. All right, let's do it numerically. So we're going to do it numerically. So it's 2. All right, 7 for rewrite execute for the user, rewrite execute for the group, and read and execute for everyone else, and into the apps apps directory here. All right, so now we're going to set the same thing to the logs. All right, now, all right, so now let's go ahead and set now in our backup and our temp data directory, we're going to set permissions on. So we're going to do chmod, and we're going to do 755 on the slash backup, slash backup, and we're going to do to uh oh, okay, all right. Now I forgot to tell you. So on a temp data, we're going to use a sticky bit, but we're going to use a sticky bit on the temp data. So let's go ahead. So basically, uh, so users can only delete their own files basically when you have that sticky bit on there. So user can only delete their own file. So let's just say someone on my team creates a file, I create a file. They can access my files, but they can't delete it. So they can't delete it. So it takes basically it's a temporary, it takes the position permissions of the owner of the file. So let's go ahead and do that. So and let's do it numerically. So you usually put a plus like U plus T for sticky bit, but let's do it numerically. Let's do it kind of an engineering way. So let's do 1777. All right, slash TMP. All right, data. All right, there we go. Okay, now let's verify everything. So let's do an ls slash ld. All right, slash apps. All right, oh, slash logs. I don't like the leading ones, but slash logs. All right, slash backup. All right, and slash tmp data. Yeah. All right, there we go. So if you notice here, if you look at it here in the directories, and the first one here, this is where our S, SGID bit is right here. Right here in the first one here, and then the logs, same area. And the reason why you see that, if you guys remember, the lowercase s is there is already an x, there's an x bit that was there. So if it didn't have it there, it would be a capital S that you would see there. And for a sticky bit, we could tell, look, it has the T at the end, right? So, so there we go. So, all right. So now that we got that prerequisite stuff out the way, so let's go ahead and create our first partition. Let's partition our first disk here. So we use the fdisk command, fdisk to partition the disk. So, and then we want to let's go ahead and use the lsblk. This is I recommend doing this so that way you don't partition the wrong disk. So this lsblk. All right. So now a couple spaces. So let's use command fdisk. All right. /dev. All right, now we want to use the MVME. Let's go ahead and copy and paste that because I don't want to mess that up. Let's copy that. All right, so we're gonna partition that disk. All right, so now one thing about fdisk, it gives you kind of like that interactive management platform here. Very interactive. So so now we're what's happening here is like we are creating logical sections on this disk, what they're pretty much partitions. Um, each partition on this lab will serve a specific purpose. All right. So if you whenever you're using fdisk utility, so you can use M for help. If you check here, you see all the different options. Now, in this lab, we're going to mainly deal with the new, we'll delete, prints to view the partitions. We'll use T for to change the partition types because that's going to be important later as well. So now in this, we're going to create 3 partitions in here. So the first one, we just want to create new for M, and we're going to just default to the primary. And then we're going to default to 1. All right. Now the first sector defaults. Second, we want to make this one plus 5G, 5 gigabytes, 5 gigabytes. All right. All right. So now you want to remove? Yeah, we're just do that. Yes. 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 All right. So let's see what partitions we have. Print. All right. All right. So we did that. Okay. So now, so let's go ahead and create another one. So we're going to create another one. All right. So P for primary, default to 2. We're going to default to the same sector. Then in this one, we're going to do a plus 7 gig. 7 gig. All right. All right. Do yes. All right. All right. So let's do P for just P again to check, to always verify. All right. So now let's go ahead and create another one. We're going to create another one. And then this one, we're going to use P for partition. And then we're going to accept the default, set the default for the first sector. And then for the rest, we'll just take the remaining space. All right. So we're going to use the remaining space for that one. All right. So, all right, cool. Now let's check a look at partitions we have. So we have 3. So you're going to have NVMe 0 and 2, P1, P2, and P3. So this is what we accomplished for this one. Now what's happening is we're gonna partition. We're gonna partition. Use partition 1 for swap, partition 2 and 3 for our LVM pool, and so we're going to be dividing to this disk space logically here. So we're going to stay here. We're going to stay here in fdisk. So if you notice here, what we're going to do is change the type change the types. So we're going to have one swap and two LVM. So to change the type, we're going to use T to change the type. So let's go specify partition one. We're going to put partition one. All right. So let's use the capital L to list the hex codes. So this is definitely what we're going to be needing to always look at here, because you could easily write swap, but here we want to always do this the engineering way. So what partition one we want to use, we're going to use the number, we're going to use swap, which is correlated with 82. And then partition two and three will use the 8E hex code. So in this one, we're going to use 82. All right. All right. So if you notice, look at it says change type of partition from Linux to Linux swap. All right. Now let's do another one. So we're going to do T again. All right. So we're going to specify partition two. So partition two, let's go ahead. We can look at it from up here from the previous command there. So we're going to type in 8E. All right. Now it says change type from Linux to Linux LVM. So let's do another one. Let's do partition three. We're going to default to three because that's what it is. All right. So we're going to do another 8E. Oh, 8E. All right. Says volume out of range. What is that? Hmm. Interesting. So we have that correctly. Okay. The remaining swap we have. Huh. So we're gonna use, okay. Well, hopefully that shouldn't matter. Ain't E shouldn't matter. Okay, yeah, okay, here we go. Okay. All right, so let's go ahead and print. All right. So here we go. So we have what we accomplished. So the NVMe 0NP1, our partition one has 5 GB swap. The last two, 7 GB, 8 GB Linux LVM. All right. So this basically going to tell us how each will be used. So LVM types pretty much allows us to do more advanced management. So to write changes or save changes, we're going to use the W command to save the changes. All right. So let's clear. All right. So now let's verify. So let's use again the ls the OK command. All right. So there is our partitions here. Okay. Now, now when we're dealing with the first partition, when we're dealing with swap. So if you notice, if we're doing a regular partition, this is where we want to make a file system for the partition. But in swap, we're going to use a command instead of make fss. We're going to make swap. All right. And I'm going to do /dev/ and then let's do the NVMe. Let's copy that one. That's the one we're going to use for this. And then, all right, make swap. There's a UUID for that one. All right, so I'm going to copy this into, okay, don't worry about this right now, but this is the UUID. This is important because we're going to need this UUID to mount this to the etc/fstab file to make this persistent at boot. All right. So now in swap, in order to, we need to do another step here. So we're going to want to turn the swap on. We're going to enable swap. So in order to swap, so we want to say we're going to use swap on. Let's go ahead and double back here, and let's go ahead and make this easier. So let's go ahead and swap on. Control E for the end of the line. All right, swap is on. Now, to see swap, to view the swap, admit again, this is more of a verification. So we always want to verify each step. So instead of swap, so you want to still use swap on and dash dash show. All right, there we go. There is our swap. So it's clear screen. Okay. So now, so let's use let's go make this persistent. As I showed you before, we're going to make it persistent using the UUID. Typically, you can just use the path, but we want to use it the engineering way, and I'm going to show you why in a minute. So we want to use VI. So you use the /etc/fstab, and here you go. So if you notice, these are all created by the system. So if you notice here, these are already uh, configured, added here using the UUID. This is definitely the engineering way of doing it. You could use it by the file path, but we're going to do it by that way. And plus, it looks cleaner, looks better. So let's go ahead and use insert, use Vim. Oh, let's go. I'm sorry. Let's go ahead and let's back out. Let's get the UID. So let me escape. Let me semicolon. Let's quit. I didn't modify anything. Oh, uh, quit. Quit. All right. So let's find the block ID. So let's go ahead and use the same path. Let's Control A. All right. Let's go ahead and use. This is a command to use the block ID. All right. Just one second. Just 1 second. All right. Right. Just 1 second. All right, so in order to find the block ID, you always want to use BLK ID, Control E to the end, and this is the block ID um, for the first partition. So let's copy and paste this ID. So let's copy here. All right, so let's go and go to the /v8 tab. So let's go to insert. So let's go here. All right. All right, let's go here. All right. So let's copy, let's paste it here. Make sure we again delete our quotes here. All right. So now what we want to do, if it's a swap, we're not mounting it to anything yet. So we're gonna use swap, swap. All right, and then oh, oh, was it a 9? Oh, all right. Swap, swap. All right, and then defaults. All right, and then 0, 0. All right, so there you go. So in order to save this, want to escape. All right, shift semicolon, WQ for quit. Boom. All right. Now, what we just did was we ensured that swap will be enabled on reboot. It's persistent. So basically, we really use the UID because we want to prevent making any type of mistakes. You can do it by the name, but you might mistype something. But the UUID is like almost like a social security number of that device of that partition. So it's pretty accurate. Now let's create a um logical volume. All right. All right. All right. So to create a logical volume, so first there's three processing steps to create. There are processing steps to creating a logical volume. All right. So first three things is you want to create. You're going to be creating a physical volume, a volume group, and an LVM. So now let's go ahead and create one. So these commands are pretty easy. Pretty has a different repetitive naming convention here. So it's pretty easy. So we're going to use the PV create to create the physical volume. All right. So let's go ahead and use the LSBLK again to make sure we just always want to, let me clear this again, make clear. All right, LS BLK. All right. So just want to make sure we want to create them on a right device partition. So first we're going to use PV create. All right. And then we're going to specify, we're going to do that on /dev /NVMe. All right. So we're going to partition the second one. So let's just copy here. I don't want to make any mistakes here on that. So let's do the same thing here. All right. And we're going to do the same thing /dev. And let's do the third partition. Let's go ahead and do that as well. Okay. All right. All right. So let's create. Was already used for the MBM2, successfully created. All right. Don't really mean much here. So let's go ahead and we create these ones. All right. So it's clear. All right. So this converts the logical volume managed into logical managed storage unit. So they become kind of like building blocks. So you start like think of that physical volume as like that foundation. So let's create a volume group. So volume groups so pretty much we're going to combine these these partition 3 disks into like a pool. So think of it like it's a big, large container for these pools. So to do that, we're going to use a command called for volume group. Here it is, VG create. So VG create for volume group. All right. So we're going to specify the name what we wanted. So we work for a company called Nebula. So let's call it VG underscore Nebula. All right. And then we're going to specify the device path again. All right. So we're going to do slash. You know what? Let's go ahead and I like to do this again. I like to do the LSBLK. But I always want to make sure I don't want to, you know, do the right the use type in the wrong device. So we're going to use VG create. I'm going to do /dev. All right, slash. We're going to do that second. We're going to use the we're going to oh we got to specify the name. Forgot that step. So we got to specify the name. We're going to, since we work for Nebula, we're going to use VG underscore Nebula. All right, then we specify the devices, the physical volumes here. So we got to do /dev. All right, slash NVMe. All right. So we're gonna do. Oh, let's go ahead and again copy that one. I'm gonna use the second one, second partition, and then we're gonna do. Let's copy this one again, and let's make it easier. All right, so let's make it. We're gonna do the third. This is the third one. All right. All right. So the nebula's been added. So okay. So we did that. All right. Remember, just think of this as this is a storage container. All right. All right. So next we want to next in the block, let's create the logical volumes. So this is an important step to remember too. Um, you know, again, there's a certain flow to each of these creating partitions, logical volumes, and swap. It's definitely a workflow. Try to remember the workflow of it. Don't spend a lot of time just trying to memorize the commands. Understand what it's doing while we're doing each step. All right. So to do this, we're going to type in, since we're creating a logical volume, we're going to use LV create. LV create. Now this is different. So let's go ahead to man LV create. All right. So if you look in here in the man page, which you have access to in the exam, so an LV create, so you want to specify this option, use these options. You want to specify this the size, and then the name, and then what we want to reference is the group. So we want to reference the group. All right, and then then our argument is going to be to the group, the physical, the volume group. So basically, this creates usable virtual partitions. They're flexible and resizable as well. So again, so this is definitely be comfortable using the man pages, because this is, if you forget what options to use, you can always come here. So let's go ahead and create the uh, logical volume. So we're going to use LV create. All right. And again, we're dash capital L for the size. This is going to be 8G, 8 gigs. All right. Dash N option for the name. And we're going to specify the log. Then we're going to specify the name we want to name the logical volume. So it's going to be LV underscore apps. All right. And then we need to specify what group volume group it's going to be in. So it's going to be VG underscore, oh, not BG, VG underscore nebula. All right. All right. The logical volume is created. So we're going to do the same thing, but with the log, the log team, the log, I'm sorry, the logs um, partition. So what we're going to do, we're going to use the same volume group, but we're just going to change the LV to logs, and then we're going to change the size to, it's going to be, instead of 8G, it's going to be 5G. Let's control E. Let's go ahead and create that. All right, so both logical volumes are created. Again, these are pretty much, now since we did this, now this creates usable virtual partitions, and like I said, they're flexible and resizable. So let's go ahead and all right, so let's go ahead and now if we want to verify the physical volume, you know, physical volume, the volume group, and the logical volume, you use the PVS command to list out the physical volumes. So if you notice this one here is NVM01, that is the system one. These are the last partition ones we created. So now if we want to look at the volume groups, you use VGS, and this is the volume groups. This is the volume groups. All right. So now if you want to use LVS, let's use volume group LVS. So let's go ahead, if we want to use a PVS dash V. All right. So this gives us a little bit more detail. So we can go and use LVS um, dash V, and here it is. Gives us a little more information. But you always want to re-verify your work. So next, after we created the logic valve, now the next step is we're going to do file systems and mount file systems and mounting. So what we're going to do is we're going to create file systems so Linux can store files. So now XFS is the kind of default for Rails, fast, scalable. But so to do this, remember We're not like make swap, what I was saying earlier, but we're gonna make a file system for the uh volume logical volumes. So you use make mkffs make fs, all right, and then specify the extension xfs, all right. Then we're gonna specify the this um vg underscore and slash lv underscore apps. All right. So now you could do now if you look at type in LSBOK, there is a mapper you could pass, but you can use this as well. Uh, so here we go. Making sure I did not want to figure that. All right, so that worked. File system created for this. So let's do the same thing for the logs. Let's do logs. Make the file system per logs. Okay. Correct. Worked. All right. Now, all right. So now we want to, let's do the LSBLK. All right. Look at this. Look at this so far. Look at how it looks so far. Got our logic volume partitions here, and we got our swap here. So let's go. So next we want to do is to mount, we want to mount to the, remember in the beginning we created it as slash apps and slash logs directory, um, device directory. So let's go and do that. So use the mount command. We're going to mount, all right, slash dev, all right, slash, we're going to specify the volume group underscore nebula, and then we're going to specify the um the logical volume, all right, and we'll specify the apps one, and then we're going to mount it to the slash apps um apps directory here. All right. So now let's go do the same thing for the logs. Thing for the logs. All right. Let's do underscore logs. All right. Now. All right. All right. All right. So let's use this clear and let's use the LSBOK. All right. So here it is. So what would happen if I just rebooted the system? So if I rebooted the system, none of this would all the work that I've done would not persist, except for the the partition is the swap partition that I did because we partitioned it earlier in a previous step. So in order to do this, in order to make this persistent, we're going to use the block ID for the logical volumes that we've created. So now we're just going to use the BO OK ID. Oh, so these are the partitions for this one. So let's go ahead and do this the easier way. So, all right, let's go ahead and the block ID. Let's do the block ID for the apps. So let's do change this up. Let's make it a little easier for us. All right. So let's do the logs. Let's do the apps. Let's do Control A. Let's change this up a bit. So what we want to do is BLKID. All right. So we're going to do Control E for at the end. Here's the block ID for that one. For this one. So let's go ahead and let's go ahead and copy this down here. All right, so then we're going to let's go ahead and find that here. It's in my history somewhere. Uh oh, there he goes. All right. So we're going to add that to our storage table here, mount table here. So we're going to come down here, do dash I, and then we're going to here, come down, and we're going to paste it here. Again, let's go ahead and remove the quotes here. And then after this too, we're going to tab, and then we're going to specify the mount point. Apps, then this is the file system XFS, and then remember defaults. All right, and then 0, tab 0. All right. So now what we want to do is go back out. We're going to save our changes here. We're going to hit escape, shift semicolon, W right quit. So now we're going to make our third partition persistent. So we're going to do the logs, due to logs. Then we're going to do the same thing. All right. So here it is. All right. So let's go ahead and do that. And let's go ahead and I for interactive is insert. Let's go ahead and paste this one in here as well. Remove Control A for, oh, no, can't do that. Let's go ahead and break the quotes. All right. So then now we're going to specify the path again. All right. And then XFS and defaults. All right. And 0, tab 0. All right. So let's go ahead and escape. All right, let's go escape and control WQ. Oh, WQ for quit. All right. So now we're going to test it. So we're gonna so basically what we just did for all this for the in the Etsy fstab is we ensure the mounts kind of survive at boot, and the UUID is really prevents these type of failures. So to test this out, we're going to use the mount. Oh, the mount. All right, -A command. All right, so nothing came back. We did this correctly. All right, so if something would to come back, they will tell you kind of what, might be something misconfigured in the fstab files or something like that. So now, now, last but not least, now maybe get in a situation where we want to just say we're running close out of space in the LVM. Um, so so by doing this, we want to we want to extend space. We want to extend this logical volume. So what we need to do, we need to add space from the volume group to the LVM, to the logical volume. There is no downtime to this, but to do this, now if you notice in our presets, we use like LV create, LV display, um, in that command structure. So it's the same thing. So we're going to use extend. So we're going to use LV. All right. Extend. All right. Dash L, capital L for the size. And we're going to specify plus 3 GB. And we're going to do that in a slash dev. All right. Slash specify the volume group we want to and extend. Um, used for the extension. So VG underscore nebula and LV underscore apps. All right. Uh, all right. So we need to add insufficient space, but only 510 available. All right. So so we did this. So we run out of space here. 7 extents needed. All right. So let's go ahead. I'm running out of meeting time here. Um, let's go ahead and increase this to 2G. All right, 2G. Well, let's just extend this to 1G. 1G. All right. I'll say that in a minute. 1G. All right. So we extended this to 1 GB, 1 gigabyte. So now let's go ahead and let's go ahead and let's go ahead and check the disk space here, what we have. So we use the df-h. All right. So this gives us a good detail of look at all our devices here with the partitions that we created. All right. See, these are right here. All right. Now, let's go ahead and clear. All right. Now, let's go ahead and let's do a final validation for everything. So we're going to do ls blk, blk. There it is. These are our swaps. These are logical bombs that are matched. All right. And then let's clear this one. Now let's check the swap using the swap on dash show. All right. Here we go. We did that. Let's type in VGS. All right. All right. LVS. All right. Now you see our increased space here we did for this one, the apps one, and then LVS, and then we did the df-h. Now let's go look at the apps and logs directory. So we use ls-ld, all right, slash apps, apps, all right, and slash logs, all right, all right. So here we go. All right. So, all right. So there we have it. That was the lab for today. But in order to now let's go ahead and do some cleanup here. So if we want to clean up, do a little cleanup here, what we want to do is first we want to unmount. We want to unmount the we want to unmount the the mounts from the slash apps and slash log. So we want to use unmount, unmount slash apps and slash logs. All right. Unmount, you mount. I always do that same thing all the time. All right, so we unmounted them. So next, we want to turn off the swap for the swap. Swap off. All right, slash dev. All right, slash NVMe P21. We want to turn that off. All right, that's turned off. So let's remove the logical bombs. So we're going to use LV remove, LV remove. All right, and -y. All right, /dev. All right, slash VG underscore nebula app. All right, so we're going to remove that and remove the logs. All right, that's been removed. Then, last but not least, we're going to last two things. We're going to remove the group nebula. So we're going to do VG remove. All right, and VG underscore nebula. All right, and we're going to remove the physical volume. So we're going to do PV remove. All right, /dev. All right, /NVMe ON 2P 2. All right, and we're going to do the other one. So let's go ahead and copy that. I'm going to copy that here. So we're going to copy that. Let me copy that naming here. All right. All right. So we're going to copy that, and we're going to make that a 3 because that was our other partition. All right. All right. So, all right. So we wiped those as well. Okay. So those are done. So let's go ahead into the this BI into the fstab /etc/fstab. All right. So let's go ahead and remove our swaps from the mount table here. So let's go ahead and move these. Go ahead and remove those. All right, let's go ahead and remove these. All right, okay. Now, so let's go. So let's go ahead and escape WQ. Um, Sometimes I might run a kind of system CTL daemon dash reload. All right. So let's go ahead. I'll see. Is A, so everything. So that's clear. All right, LSBLK. All right. So let's go ahead and remove these partitions. So let's go into fdisk. Fdisk. All right, /dev. All right. All right. So let's delete. All right. Let's delete. Delete one. All right. Delete. Let's delete two. All right. And delete. Three. And three has been deleted. So let's clear. Oh, oh. To make these correct, let's write that. All right. So let's do a clear. And let's do a LSBLK. All right. All right, there we go. Start fresh and new. And thank you guys for joining me on this Sunday. And thank you guys. That was it for the creation to cleanup. If you have any questions, please post comments in the YouTube video. Thank you guys. You guys have a great and wonderful day. Thank you. Bye bye.